Unit 3, Lesson 8. So we're going to use our graphing calculator to find max and min values, and we're going to do applied stuff with max and min. Can anybody think of a real-life example, there's kind of one that's a major one, of where parabolas are kind of in the real world? Yeah. Yeah, what creates throwing a ball? What makes it have an arc? Gravity, right? Yeah. Gravity is the main pull of parabolas. Everything that goes up has to come down. Everything you throw has to come down. And parabolas represent that relationship. Okay, so parabolas are not just useless math things that we're never using. Okay, parabolas actually have physics and stuff behind them in terms of velocities, how things fall, and everything has its own little equation. But in terms of using your calculator to find a max or a min, okay, so this is the steps to using max and min. Okay, a lot of you need a little bit of help on finding the zero. Okay, you got to be able to use these calculators. They're very powerful tools. Okay, if you can't use them, then you're going to miss a lot of easy questions. So enter the equation of the function, so y1 and press graph. So we're going to enter an equation. Let's go with negative. Whoops. Let's go with negative 5x squared minus 5x. Let's go plus 21. Let's see what that gives me. So in your calculator, you put negative 5x squared plus 5x, minus 5x plus 21. I haven't used this in a little bit, so we'll see what it gives me. Okay, so I'm going to make my window probably 50 in terms of my max for the y, so I can get the top of my graph. Okay, so I changed my window to 50. Let's see if that helps. Okay, good. Now I can see my full graph here. Okay, so now is this picture here, is this graph here, is it a max or a min graph? It's a max. It's a hill, right? It's a hill. So with these calculators, you can also find that. So again, go to your second trace, okay, and maximum is number 4. And it's the same left-bound, right-bound. It's a little bit easier to tell this time. So if I move, let's move my cursor here. My cursor's there at the top. You can see it. So that's the max area. I want to be left of it, the left-bound again. Okay, so I'm going to go left of it, hit enter, and then right of it, I'm going to go over the hill and the other side of it, and hit enter. Whoa. And then let's go somewhere close to it. And hit enter. And then it zeroes in on your maximum. Okay, now what is my actual maximum answer? Is it the x or the y? It's the y. Good. Max and min is your vertical. Okay, so 22.25 is your maximum. Now, what is this whole point, though, in terms of what we learned in Unit 3? Okay, and I'm not going to be mean, but if you can't answer that now, you have some studying to do if we're taking the test on Friday. The vertex. Good. That top point is your vertex. So this point right here is your vertex. So I'd call that negative 0.5, which is a half, or negative half, and then 22.25 is your Q. Okay. So if we went ahead real quick here, we wrote this equation. Well, I'm going to say that's negative 0.5. You would write it like so. Okay. We don't know what A is, but that's okay. X plus 1/2 squared plus 22.5. That's what your vertex form would be, or standard form would be. Okay, and it'd be y equals, we wouldn't know what A was, and to find A, what do we do? That's Unit 3, or Section 3. What could we do to find A? What's that? Nope. We just put in one point. Yeah, an x and y coordinate. We just want to put an x and y coordinate, so we have to just solve for A. And when you have something like this, does anybody know where you can go find x, y coordinates really easily? Anybody? Table thing, yes, correct. Okay, so the table thing. So if I come over here and I hit second graph, it'll give me a table, and then I would find any of these points that look nice, like 2, negative 9. Plug that in. You now have a point on that graph. When you have a graph in your view, the table that when you hit second table, that goes with that graph. Okay, so it's not going to be from anything else. All right, does that make sense? Okay, it's helpful stuff. And that's what I'm saying, like, I'm being completely honest, if you're really good with your calculator, you can get a lot of this stuff done very easily. Okay? A lot of this stuff done very easily. Okay? All right, so let's go back to the lesson here so that I just kind of talk through this part. Okay, so we're good with that. Let's do the first example here. Okay, the height h in meters above the ground of a projectile at any time t in seconds after launch is defined by the function negative 4t squared plus 48t plus 3, with t being time, h being height. So one thing I want you to understand when they're saying stuff like this, what is the independent variable, time or height? So remember, x is our independent, right? Y is our dependent, because y comes from what x is. So does time determine height, or does height determine time? What did you say? Time determines height. So what I'm saying is, in this example, t is my x, h is my y. Okay, in terms of your thinking. Okay, so when you're putting this in your calculator, like, well, there is no t. Well, actually, on your calculator, I think, doesn't it say x, t, theta? See how that we're at your x button? There actually is a t there, because time is usually an x. Okay? All right, so it says sketch the relevant part of the parabola on the grid. So use your calculator. So let's put this in. I'll let you guys put that in and tell me what it looks like. I do know it's going to go through 3. Why do I know that? Yeah, it's my y-intercept, right? It's the constant. It's plus 3. It'll just be an x. You have to just have it be an x. What? Yeah, but you just hit it and it's just an x. That's fine. That's the same thing as a t. Yeah. That's why I was just telling you that t is x. Yeah, I don't think so. Might be able to, but. Okay. It's a straight line. You might be zoomed in too much. Yeah. What's your window? Here, hold this. You have to change your window to this. Let me see. Yeah. Okay, so James has a really good window here. So here's the window you can do. Your x-min, -10. Your max, 15. Your y-min, -17. Your y-max, 200. Okay? That'll get you a nice, good picture of it. Okay? And then that looks like something like that. Okay? Everybody following with me there? You want to learn how to use this too? You know, I might borrow my calculator for free. Okay? All right, so we sketched it. Find the height of the projectile after 3 seconds. So what does that mean? What are we going to do? You can plug 3 in, good. Or, since we know how to use our calculator, what's another thing we just talked about? It's the table. Just go second table and look at x is 3. Okay, what is it? Okay, so it's 3 seconds. It's 111. You can use your table or plug 3 in. Either work. Okay? Find the height of the projectile. Oops, I put that in the wrong spot. Sorry. Find the maximum height reached by the projectile. So we want to find max. Can somebody find the max for me? What is the maximum there? We'll do the maximum thing. See what you get. 147. And at what time is it 147? 6 seconds. 6 seconds. 147 is your maximum. You can get that by doing the maximum tool we just used. Oops, I keep doing this the wrong spots, dang it. Say it again. No, it's just 147. I just wanted you to know it happened in 6 seconds. That's all. Yeah. Yeah, see, it's right here. Next question says how many seconds, so it'll be 6 seconds. Okay. What was the height of the projectile at the launch? So at 0 time, where is it launched from? 3. Good. Right here. The y-intercept. 3. So what would that account for? Let's say it's throwing a ball. What would that make? What would make sense? What's the 3? Yeah, it's your hand because it's off the ground, right? So you're throwing it from your hand. Good. Determine when the projectile hit the ground to the nearest tint. So how can I figure out when it hits the ground? So this way, why is this one impossible? I want you to make this connection. Because there's 2 zeros, correct? It's behind you, but think about it in terms of x. What is x? X is time. What is this side? Are we going back to the future? See, we can't have negative time. We're not going back to the future. So all of our stuff has to land in the positive time. Does that make sense? So you want to find the 0 on the far right. Okay? Somebody help me out with that one. What'd you get for the 0 there? I know, that's why you got to keep up. Okay. Yeah, it's this one right here. What did we get? 12.1, that's correct. Good, 12.1 seconds. Probably not a baseball, that's a long hang time. You can throw a baseball for 12.1 seconds. Home runs don't last that long in the air. Okay. All right. Are we good? Okay. No, just make an X. Your T's are X's. Okay, I'm going to go away from this for a second, Gabby. You can catch up a little bit. Or you can just watch the video. All right, so last season, a struggling hockey club had 7,200 season ticket holders. The owner of the hockey club decided to raise the price of a package of season tickets to the new season to generate more revenue. So, sorry, I kind of butchered that, but he's raising prices to get more revenue. Okay, the existing cost of the package of season tickets is $1,400. So right now they charge $1,400. Before raising the price of a package of season tickets, he hired a market research company to gather data on proposed increase. The research company reported that for every $25 increase, they'll lose 100 season ticket holders. Okay, so they won't renew. So that's kind of important information. So for every $25 they increase the season tickets price, 100 people will say, I don't want it. Okay, so if the price increase is to be a multiple of $25, use the following procedure to determine what price would maximize the revenue from season tickets. All right, so let X be the number of X $25 increases. All right, I'm on the wrong page here. Okay, so cost is $1,400 plus 25X. So it's already $1,400, and they're going to raise it a certain amount. Okay, so that's why the X represents what? The X represents how many $25 increases there'll be. That's why it's times 25X. We okay with the cost increase equation? Okay, the second thing is the number. So number of people. So how many number of people do we have? 7,200. And then how many people do we lose per X? 100. So it's 100X. That's how they're related. Do you see that? So for every 25 X's I raise, I lose 100 people. 100X. Okay? So we're going to use the results to generate an equation. And what we can do is we can find a maximum to maximize our profit. This is actually what people use in marketing and what those type of things, accounting, to maximize revenue. Okay? So what we're going to do is we're going to multiply these. Okay? We're going to go 1,400. Whoops. 1400 plus 25x times 7200 minus 100x to get our quadratic. Okay, when we do that, you'll get this. It's going to be kind of big, but you're going to get 10,080,000 plus 40,000x minus 2,500x squared. So that would be your quadratic equation. 2,500. 2,500x squared. Yeah. So it's 10,800,000. No, 80,000. I was right. 10,080,000 plus 40,000x minus 2,500x squared. Okay. So then you're going to put that into your calculator, and you're going to want to. I don't have the table on here. I did before. Okay. So you want to put that in here, and you're going to get something that looks like this. It's going to be a very, very big parabola, okay? And you're going to have to, obviously, you're going to have to change your window to quite a bit. You can also use a zoom fit if you know how to use that on your calculator as well. So let me read part C while you're doing that. So determine the price of a package of season tickets which would generate a maximum revenue. Okay, so we want to find the max. So you guys you're trying to find this highest point here. What's that? Yeah, down here. Yeah. Did anybody find the max yet by chance? Or anybody have any success zoom fitting on there?
Yeah, almost.
Almost? All right. Good. What did you get, Liam? Okay, did you find do the maximum now? Good, do the maximum. I see some good graphs. Good job. Good work. Yeah, good. Find the max now. Do that maximum method. You got 8? That's correct. Good. So x equals 8 is the maximum. Okay, what was your y? Right. See, that right there is the maximum, the revenue, but we don't want the revenue, we want the profit. So we can figure out, it says, we want to figure out the max price. So if it's 8, the maximum price they should charge would be $1,400. So here's C. I'm doing it up here just so I can keep my work here. It's going to be $1,400 plus 25 times 8. That'll tell you the max cost you should charge to make your most money. Okay, so Tom, on his picture, right here, his max he got was 8. X equals 8. Okay, and then his Y was some really big number because that was the total revenue. Okay, the big revenue that you would make for the year. Okay, we want to figure out the actual cost of the tickets. Okay, 25 times 8 is 200. So we want to charge $1,600 per season ticket package to maximize our revenue. Does that make sense? Did I lose anybody yet? So what we did was, what we did was that we found the max was at x equals 8. That means I want to increase my ticket prices 8 times $25. Okay, by doing that, the 8 times $25 was $200 added on. $1,600 is the price, and the next thing we're going to do on part D is we're going to figure out how many people we're going to lose in terms of ticket holders. Okay, all right, so we're going to go down here. For ticket holders, how many will we lose? Okay, we plug it into the other one, the number. We go 7,200 minus 100 times 8. We lose 800 people. So we'd get 6,400 people would be our new season ticket holder population. How much more revenue would be generated if the plan in C was implemented? So now we need that number that Tom had. So what was that? What do you guys have for that number? So the original revenue was, excuse me, never mind. I can just do it this way. It's a little bit easier, actually. Our original revenue was 1,400 times 7,200 people. That was our original revenue. It was $1,400 per season ticket times by 7,200 people. That gave me 10,080,000. Okay, but now we're doing 1,600 times 6,400 people. That's going to give me 10,240,000. I just would subtract those to figure out the difference, and the increase in revenue, we would now make 160,000. That's how much money we'd make. So if you made that move and said, forget the fans, you'd make another $160,000. So we can pay Tom to be a high-paid janitor. Okay, 160,000. All right, any questions on that? Okay. All right.